So let's open the implementation file for our main window and take a look. Okay, so the control the name of the control that we're given to our progress bar is called bar progress. So it's not very difficult to identify it. I just press Control F and I can this way I can highlight the entire code associated with it. Alright, so first of all, let's just see what happens. We use the main window show, which is called from our main function. So here we're adding new sets of calls for the progress bar. And first of all, we hide it. Basically, initially, we want to make it invisible. So it's very easy, just like with all other gadgets. There's a member function named hide. Now, in order to maintain the progress bar indicator, we initially have to set the range for the minimum and maximum values that we would like to indicate. So the minimum in our case will be 0 and the maximum will be 1. So these are double values. So we set it into, configure it to the range 0.0 to 1.0. So this is from 0 to 1. Then also we can set the background color for the bar background. Right, so this is the entire bar. This is like the progress indicator. So this is the background color, of course, for the background, and this is the progress bar color. So this is the indicator color right here. So these are the colors that I took from just pick it from HTML. So this is a kind of grayish version, and this is more a bluish version of the indicator. And then, because these are kind of dark in their shades, so I'm using white color for the label display, for the label that will be displayed in the middle of this progress bar. So just pretty simple configuration, and we just hide the progress bar at the beginning. Then let's just run this application one more time to display our window. And so here, when we first click the button, right, we already know that the call is dispatched to callback button animate, which of course invokes the member function right here. Okay, so it invokes this member function right here, which starts the animation sequence. However, just before it does this, it of course displays, right, makes initially the progress bar was hidden, so now it becomes visible. It sets the label to 0%, and it sets this value, which is supposed to stay in this range from minimum to maximum. So it sets this value to 0.0, right? So it sets this value exactly to be 0.0. Okay, so these three things takes care of the label, takes care of the internal value kept by this gadget, and then makes it visible. So now the animation begins right here, and we can examine all the code that is involved with the animation itself. So once the initial timeout is invoked, because as soon as we click the button, we end up over here and we request our first timeout. Basically, we make a call into the library and we say, okay, let's start timeout. And this callback animation right here, callback animation, this is where we start our first animation. So the system invokes this static function, callback animate, and of course this does the same thing, except when the animation stops, remember we use animate to check the progress count, and when it becomes 0, we return false from animate, and in this case we again hide the bar, the progress bar, at the end of the animation cycle. So this is why the animation bar, which we would see right here during the animation, is most of the times just hidden from the user, because we hide it at the beginning and we hide it at the end of the animation cycle. And what we do next is, I mean, of course, we're doing exact same code executed right here, which drives the animation. We have a condition that stops this, but unless or as long as this condition is true, we just say repeat, right? So we repeat, we tell the library repeat, and it calls us again, and we decide again whether to repeat or not. And this is how the progress bar makes its display through sequence of calls. So now we can really kind of focus on the animation function itself, right? So this animation function is called every time the animation happens. At the beginning, the progress count is set to the maximum progress count. So we still maintain the display for the sake of just debugging reasons, and you know, as a checkpoint right here, we display the progress count so we can trace its actual value when we run the animation. So once again, we can just try this very quickly, just run this animation one more time, and this is what is shown. This is what is shown on this line, right? So these outputs clearly indicate every single call into the animate function. And again, at the beginning, we just check whether this animation is supposed to continue or not. Then we decrement the count, so the count gets updated inside the window. Then we need to construct a new label. So what we do here, we're using this formula that we know that this is the maximum value for the progress count, and it goes from this number to 0. So we invert the value by taking 10, in our case, and subtracting the current value of progress count. At the beginning, progress count is set to 10, same value, so we get a 0, and then it becomes, when we subtract it, it becomes 1, 2, 3, 4, 5. So we multiply it by 10, we also append the % sign, and we save it in this memory buffer that we construct right here, right? The output string object, which is just a memory buffer, like this, where we can conveniently write the information using the standard output stream formatted output style, everything that we like. So we populate it with something like 10%, right? 10% and 20% and so forth, and then we simply convert this to a string, and we have a dedicated label for this, which is a string. So this buffer has a member function stir, which returns the string, and then we pass into the label, we pass the cstir. So we have to convert this string that we update right here as a result of this dynamic update, and we convert it to C style zero terminated string by calling cstir on the string. And this is what the progress bar gets as a label. So this is the label that's being displayed. So that's this, it's configured here with everything like the numeric value and the % sign, just to make a nice indicator to the user, and everything gets updated. And then this is an interesting call right here, FL check. And what this does is basically when we have these callback notifications, we're taking CPU time away from the actual time needed to update the window. So calling this during some kind of work done, in the middle of other work done, just basically keep the screen, this entire screen, our window, up to date and makes it continuously responsive. So it's a good thing to have in the middle of animations and during some other loops or computations during which we could be kind of freezing the responsiveness of our window. So this is just an interesting call to note, and so we're trying to keep everything responsive, and so we add this FL check, which is sort of suggested by the documentation, by Fulltech documentation, to keep it up to date and all good. We just add this call just before we finish every animation cycle. So in summary, our show function, which is configuring the entire, basically this is the function that configures the entire window and set of all the gadgets. So initially the show hides the progress bar widget, and when the application starts, only the animate button is shown on the screen. Okay, so we can see that right here. And then the next thing, when we callback button, basically we click the button and we get the button click. What happens is that we begin the animation cycle. We reset the initial progress bar label and numeric value to 0. So this is happening right here in the callback, right? So in this static callback, we use the window pointer and we just reinitialize the state of the progress bar here and make it visible. And finally, we know that during the animation cycle, this animation function is invoked, so it updates the progress bar label and computes the value according to the progress count value, right? So the progress count basically drives the actual progress that is made visible during this animation. So this concludes the series of our laboratory exercises, and this project demonstrates that you can get callbacks not only from the actual gadgets, so you can attach your callbacks to whichever gadgets you want, but you can also ask the library or ask the system or operating system to notify you at specific periods of time. And so this is yet a different type of callback, which we normally refer to as a timer notification. And that timer notification could also be used to dynamically update parts of our user interface. And of course, the progress bar is a good example of the situation where we have to be able to somehow calculate the state of the progress bar and be able to display it. So for that, we need specific time intervals to be able to consistently update the progress bar, in our case, to make it appealing to the user. Right, so that's an example of this type of functionality.